Hello, Eric and I are going to explain figure 7.5, which is called satisfying warp. And in doing so, we're first going to need to explain the graphical representation of the violation of warp, which is figure 7.4. So I'm going to do that, and then Eric is going to explain figure 7.5 and the necessity for warp. So here I have the two axes, x1 and x2, and the two budget lines for this consumer of choice, which I labeled as budget line 1 and budget line 2. And the two optimal bundles of goods. For budget line 1, we have x1, x2, and for budget line 2, we have y1, y2. And in order to understand this better, in order to understand why this consumer is not maximizing his or her own utility, we have to draw out the budget sets. So the budget set for budget line 1, this one, is going to look like this. And that clearly shows that bundle x1, x2 is revealed preferred to y1, y2, because bundle y1, y2 sits within the budget set of budget line 1 and not on the budget line, which x1, x2 does. And how we'd algebraically represent that is with the first budget set equation. We'd say that p1x1 plus p2x2 is greater than or equal to p1y1 plus p2y2. And what that means is that the bundle x1, x2 is revealed preferred to y1, y2. And then the second budget set is, for budget line 2, looks like this. And what that means is that y1, y2, which lies on the budget line 2, is revealed preferred to the bundle x1, x2. And how we'd algebraically represent that is the second budget set equation. p1y1 plus p2y2 is greater than or equal to p1x1 plus p2x2. And clearly, what this means is that the bundle y1, y2 is revealed preferred to x1, x2. And these two equations, these two inequalities are clearly in contradiction because one consumer cannot prefer x1, x2 to y1, y2 and at the same time prefer y1, y2 to x1, x2. So this consumer is clearly not maximizing his or her own utility, and that's why we need the warp principle. And Eric will explain that.
Sure. So now I'm going to explain to you how this satisfies warp. So in this example, I've drawn the same graph. I have the two different budget lines. I have budget line 1 and budget line 2. However, the bundles are in different locations. And the location is extremely important because now each other bundle is no longer affordable to the other one. So let's say when I shade in this budget line, right here, budget line 2, this bundle lies outside, while I shade in budget line 1, this budget line lies outside it, so it is no longer affordable. Thus, it's possible for us to then show that one is preferable to the other with these two indifference curves, thus satisfying warp. Thank you.
Wait, and one last thing quickly. It's important to know that the two indifference curves that Eric drew do not intersect, which is an important property of indifference curves. And yeah, and that is all. Thank you.